Okay, let me give you guys some more practice. So here we've got a straight line. Here we've got a straight line. Y equals x plus 1. If you revolve this 360 along the y-axis, you're going to trace out a cone. Okay, and we're trying to heat up some water. So if we were to put out the fire, then at this moment in time, the temperature down here is 87 degrees Celsius. Up here it is 23 degrees Celsius. If we were to get a spoon and then mix up everything here, at what temperature will the water settle at? Okay, so it's really me asking you to find the average temperature. So press pause and have a go. Okay, so to do this, there's an easier way of doing this, but let me show you the hard way first, because I want to illustrate a concept to you. So now the hard way, right at the end, I will show you the easy way, maybe in the next video. So the average temperature here, don't forget at the moment it is 87 degrees Celsius down here, and up here is 23 degrees Celsius. The average temperature would be you evaluating this. So if you think about it, you're trying to sum up all the disks. Okay, you're trying to sum up all the disks. So as y is moving about, let's just look at one particular disk. Let's just look at this one here. The thickness of this disk here is dy. Okay, and you're summing up all the disks as you're moving up in the y direction. The temperature is moving about. The temperature is changing. So we've got to try and take into account the temperature as y is moving upwards. So look at the graph here. The temperature here and y here. Don't forget y is moving about. Y is moving about. Before y reaches 1, we don't really care about it. We don't really care about before y reaches 1. Okay, but the thing is, we need to come up with an equation to model our temperature. So don't forget we're summing up all the disks. So as y is moving upwards, we want to know the temperature at any given y. So let's say we want to know the temperature right here at any given y. So the thing is, y is moving about. So when y is 1, we want to somehow set it up in such a way that the temperature when y equals 1 is 87 degrees. So when y is 1, we want to set up in such a way that the temperature is at 87 degrees Celsius. And don't forget y is moving along. So the weird thing is that y starts from 0. So it's moving along. So by the time it gets to 1, we want to set up in such a way that the temperature will be 87. So that's this point here. And then y is moving along here. So by the time y reaches 4, we want the temperature to be 23. So by the time y reaches 4, we want the temperature to be 23. So now basically we want the equation of this line here. We want the equation of this line here where it crosses here and here. Okay, so the equation for this straight line here is really this bit here. Okay, so we now need to know the equation of this line here. Well, the equation of this line here is given by the equation of that line there is really u. Remember the equation for a straight line, it would be y take away y0 over x take away x0 equals a gradient. Well, the gradient of this thing here would be the height, which is the difference of the two here, which would be 64, and then the across here is 3. Okay, so this is the equation of our straight line here. So this is the equation of our straight line here. Don't forget, once we've got our equation for this straight line here, this straight line here represents our temperature, represents a temperature that, and then we've got to sum up all the disks. Okay, so we've done this several times, so hopefully you will understand up to this stage here. So the equation of this straight line here is given by this. is given by this. Okay, so now it's just rearrange it. So the equation of that straight line is given by this. Okay, so now looking back at the original problem, the average temperature is given by this. So this is our temperature, and then this here is really us summing up all the disks. So if you look at this, we're summing up all the disks here. So let's look at this particular disk here. The radius of this disk here is given by y minus 1. Okay, so this is our radius here. This is our radius, which is this. So it's going to be pi r squared, or you put this into the radius here. So this is our radius here. Okay, so hang on. So the average temperature is given by this. Okay, I will continue in the next video.